Okay, here's the last video on power supplies. In the past one, or the one we just finished, the one on Zener diodes, you actually created a DC power supply from the AC source, through the transformer, through the bridge rectifier, through the cap, then through our Zeners. And we picked the Zeners for the value that we want in our DC source. Now we're going to create one, and we're kind of limited using this online software, but we're going to create one using what's called regulators. A regulator is just that. A source goes in, a voltage goes in, and it kicks a voltage out. You can have 5-volt regulators, you can have 12-volt regulators, which means, let's say you have a 5-volt regulator. You have an input and output and a ground, which I'll show you in a minute. The input has to be higher than 5, of course, because you want to get 5 out. And it kind of does similar to a Zener, where it creates a real nice DC waveform for us. But it also regulates the ripple, it regulates all the stuff that we need. It gives us essentially the cleanest DC signal that we can use. Now, unfortunately, this is where we're limited. I was kind of excited when I saw this linear regulators down here, but they only give us one. And this one is a variable regulator, which is okay. The problem is it's variable, and so we have to put some more circuitry in here to actually make it work. A normal regulator, for instance an LM7805, the 05 means for 5 volts, this would go straight to ground. This pin, we would put that same signal in here, which is that little ripple voltage of about 10.4 volts, and we would get exactly 5 volts out. If we put a 3-volt regulator, we'd get 3 volts. A 9-volt regulator, we get 9 volts. As long as we have a higher voltage on this side, we're good to go. This is, like we said, about 10.4 here. We couldn't put a 15-volt regulator here. We wouldn't get 15 volts out. All right, but here we are able to create a supply that's variable. In other words, we're going to put a potentiometer in, and that potentiometer is going to control it for us. Now, you're all familiar with the potentiometer, so I do not have to, I want to mirror that, do not have to go into that. And it does take another resistor. Again, I'm not going to get into all the numbers. Hopefully we'll do that at a different time. But I guarantee you, if you go and if you look at the LM317 specification, every value that I use here is in that specification. In fact, that's where I got it. So once again, the specification is key. The specification tells us what these two values should be. And now, just for giggles, oops, I'm going to put this one at 200. And this is a typical test circuit. You'll find it in the spec, actually, and I'm going to put that one at 750. And this will give us a range good enough to see. So this is just a potentiometer. It's a little component that we can adjust, a variable resistor, and this is a fixed resistor. And basically what we're doing is we're controlling how much of this current goes this way versus how much is going to go this way, and it's kind of a little feedback loop here. Easier to see once you have it built and then once you kind of start playing with it. Okay, so we're at 50%, so we're right in the middle. 200 ohm. Let's do our split screen. I'll put this over here. I'll hit play. That's interesting. Oh, sorry. I didn't put our points. So it didn't know what to do. Now let's try. There we go. All right, so this is the exact same as it was before. There's that little 10.4 ripple voltage, okay? But this time now, the voltage out, coming out of the LM317, the voltage regulator, is about 3.7 volts. That's based on where this potentiometer is. I'm going to double click on that, and if you see, I can change the potentiometer, which in turn changes the voltage level. So the values that I have picked right here only go from, they never get down to 0. If I go all the way on one side of the potentiometer, it's just over 1. It usually never goes down all the way to 0. This one, because of the values I have picked, goes up to 6 volts. So this would be considered, even though it doesn't go to 0, a 0 to 6 volt power supply. If you needed 3.3, you just turn it to where you have 3.3. If you needed 5, you turn it to where you got 5. This is the type of power supply that when we get back, you guys will build. It's a variable power supply. The one you're going to do is a 12 volt variable power supply. It will go from 0 volts to 12 volts. All right, that is all I have to say about power supplies. I hope this was enough. I know it's tougher when we're not actually building this stuff. I had plans for you to build the rectifiers, measure the rectifiers. That's why we did the oscilloscopes. But this is kind of our scope right here, I guess, that we're using. So it is what it is. This will end the unit on power supplies until we get back, and then you physically build one. But hope everybody is healthy, and hope to see you soon.